In the world of data, we are obsessed with exact numbers. We see headlines claiming that exactly 48.2% of people prefer a certain product, or that the average salary in a city is exactly $54,321. But here is the truth that statisticians know. That single number is almost certainly wrong. Welcome to the world of confidence intervals, where we trade the illusion of precision for the power of honesty in uncertainty. When we take a measurement, like the height of people in a city, we rarely measure everyone. Instead, we take a sample. This creates sampling error. Imagine a jar full of thousands of jelly beans. If you take a handful, the proportion of red beans in your hand might be 20%, but the entire jar might actually have 22%. That 2% difference is the hidden gap between our data and the absolute truth. This is where the Central Limit Theorem comes into play. If we were to take hundreds of different samples from that same jar, their averages would form a beautiful, symmetrical shape, the normal distribution, or the bell curve. Most of our sample means will cluster around the true center, while few will wander far away. This curve is the foundation of modern inference and the map we use to find the truth. A confidence interval is not just a range, it is a statement of reliability. Instead of saying the average is 10, we say we are 95% confident the average is between 8 and 12. This range is built using the sample mean plus or minus a margin of error. This margin depends on how much variation exists in your data and how many people you surveyed. Let's talk about the confidence level. Usually, scientists use a 95% level. This is a subtle but crucial concept. It does not mean there is a 95% probability that the true mean is in your specific interval. It means that if we repeated this experiment 100 times, creating 100 different intervals, 95 of those intervals would successfully capture the true population mean, and 5 would miss it entirely. There is a fundamental trade-off between precision and certainty. If you want to be 99% confident, your interval must get wider to catch the truth more reliably. It is like trying to catch a fish. A huge net makes you certain you will catch it, but you don't know exactly where the fish is in that giant net. A tiny net is precise, but you will likely miss the fish altogether. In the real world, this has massive implications. In political polling, a statistical tie happens when the confidence intervals of two candidates overlap. In medicine, a new drug's efficacy is measured by whether its confidence interval stays above a certain threshold. Without these intervals, we would be making life and death decisions based on exact numbers that are essentially noise. To wrap up, remember that in statistics, being vague but right is much better than being precise but wrong. Embracing the margin of error allows us to quantify what we do not know. Next time you see a single exact percentage in a report, ask yourself, where is the interval? Precision is a goal, but understanding uncertainty is true wisdom.